Alright? Because when we have a fraction, something in rational form right here, don't we have to worry about what's going on in the denominator? Same concept, okay? Now, I'm going to graph my vertical asymptote at x equals -4. Is that a vertical or horizontal line? Vertical. Okay. Now, I'm going to make a table. What number has to go in there, I told you every time? 0. Now, you're going to pick a number to the left and right of your vertical asymptote. What's to the left of -4? What's to the right of -4? Those are your three numbers in your table. Now, I want you to use your calculator, and I want you to plug those numbers into that original function and find me the value. Guys, don't try to plug that whole thing in your calculator at one time. I would do the numerator, get that answer, then get the denominator, get that answer, and then divide the two. Because if you try to plug that whole thing in there, you might make a mistake. Now, 0 is easy because all your x's cancel out, and then you have -3 divided by -4, which is 0.75. Because if you're plugging 0 in, that's 0, 0, 0. -3 divided by -4 is 3/4 or 0.75. Now, if you're having trouble plugging in, ask your group members for help. But you should get -5 is -3, and -3 is 3.
And 0 is 3.
Mm-hmm. After you do that, you need to graph the function, because before you graph it, you need to make sure that you know what it's going to look like. So 3x minus 3 divided by, put your numerator in parentheses, put your denominator in parentheses, or you might mess up, because it's going to read it wrong if you don't. If you look, we do have that vertical asymptote at that x equals -4. We have a horizontal. It does not cross the horizontal asymptote here, so we would not draw it across it, okay? So, I'm going to graph my points. -5, -3. Remember, they get very close to the asymptote, but they do not touch it. -3, 3, 0 and 0.75. And that would be my answer. I always forget the hole. Thank you. Thank you. Don't forget about the hole, please. What you do, what you should have done, Mr. Hester fix this. The hole is at x equals 1. So what Mr. Hester does is just go right above the 1, and I just draw a hole there. You will not see the hole in your calculator, but the hole is at x equals 1, so I just go above the 1 where my line's at and put a hole there to let me know that you do recognize that there's something occurring at that spot. Thank you. If you want to go on and put a kind of a hole there when you do your asymptote, it's fine. All right, let's do another one. Number 2. What is your, okay, the degree, what's the highest degree in the numerator? 1. What's the highest degree in the second one? 2. Yep. All right. So y equals 0. So horizontal asymptote is y equals 0. The next thing I'm going to do is factor it so I can find out what values cannot go in my function, because we have a fraction, a rational function. We got to worry about the denominator, don't we? So I'm going to factor this. Can I cancel anything out of my denominator here? No. So do I have any holes in this problem? No. I got 2 vertical what? Asymptotes. So I got vertical asymptote at x equals -9 and 1 at x equals 5. Alright, so I'm going to graph this. 1, 2, 3, 4, 5, 6, 7, 8. Oop, I got one over here somewhere. My graph's not big enough. And then x equals 5, 1, 2, 3, 4, 5, 1, 2, 3, 4. Okay. Now, remember, when you just draw the table, Dylan, you can worry about the notes right now, and then I'll write you a pass the next class. You can do that trig quiz at the end, okay? Okay, so remember, we always pick what point? 0, okay? Next, you pick a point to the left and right of each vertical asymptote. How many vertical asymptotes do I have? So, what's to the left of -9? Okay, what's left right of -9? 8, and then you got 4 and what? 6. 5 falls between 4 and 6. So I want you to take your moment to plug those numbers into that function. You're going to get some weird decimals on this one. Yeah, but the reason I wouldn't put it as a fraction, because a decimal, you can graph that better. You might have trouble with where the decimal goes. Like I just rounded to the nearest tenth. Like 0, I got -0.13. I mean, I did 2 places for that one. But -10 is -1.6. -8 is 1.3. If you're having trouble finding out how to evaluate these things, raise your hand. Let me come help you. I guarantee if you just take one at a time, do the numerator, then do the denominator, and divide them, you will get the right answer.
So you don't round it up, you just go to the one decimal place?
Yes. Because you round it up, you're not going to get the right. Because if you did -1.6 up to -2, that's not going to give you the correct spot. Okay, are we good on those points? Are we sure? Are we good on how we determine those points? I need a hand signal. Alright guys, then you got to ask me questions. Okay, look here. you're taking these x values, and then plugging it into this right here. So I'm going to do one for you, negative 10. Watch this. 3 times negative 10 plus 6. That's my numerator. Now plug it in the bottom. That's my denominator. So now I'm going to take negative 24 divided by 15, negative 1.6. That's how I got that. Okay? Negative 8. Numerator, denominator. Denominator. Now divide those. 1.4. Well, I did 1.3. It should be 1.4. Okay? That's how I'm getting those values. Does that make sense to you? Just don't try to put it all in there at one time. Alright, now, it's very important. Let's graph this. And the reason we graph it is to see if it crosses the horizontal asymptote. That the horizontal asymptote is at y equals 0. Oh! What you notice in that graph? It crosses the horizontal asymptote right here, don't it? Now on the other ones it does not, but it does cross there. But if we didn't have graphed on the graphic calculator, would you have known to do that? So that's why we graph. It's very important you graph it, okay? So let's do this. So let's graph our point 0, negative. We don't have any I'm about to show you, okay, buddy? Let's look here. Negative 8 is 1.3. 0 is negative 0.13. 4 is negative 1.3. So this is going to get very close to this. This is going to get very close, and then it's going to cross. You're just going to make it cross. And you're just sketching the graph, guys. This is just general sketch. So I just crossed it and connected this point to this point, and then this point. And that would be my graph. I just want to make it look like that. So I basically connected this point, and this point, and graphed it. All right, let's look at another one.
Is that the same way as the calculator was?
Okay, I got that curve. I have this curve. I have that curve. Then I go. Now I'm not going to get just exact like the calculator because it gets very close and then just shifts downward. But I made the general. I know that this looks funky right here to you, but as long as you connect the dots, you're good. All right, number 3. What's our first thing we do? We find our what? Horizontal. The degree is higher in the what? So your horizontal asymptote is y equals what? 0. If you just put 0, I'm counting that wrong because this is the equation of the line. The horizontal, that's the equation of the line. Y equals 0. That means there's a line, imaginary line going through that, okay? Now, I got to do some factoring. Can I remove anything there? No. So do I have any holes here? So what's the 2 numbers in this world that cannot go in this problem? And 3. And what occurs at both of them? Vertical asymptotes, okay? So let's graph those. I'm going to make a table. What point do I always put in there? 0. What's the number left and right of negative 3? 4 and negative 2. And 3 is what? 2 and 4. I want you to plug those values in and find me the values of those. A -4, did y'all get 0.1 or 0.14? Okay.
Dylan, you look at me for a minute, 'cause I'm going to catch you up with graphing. So Dylan, when you're graphing rational functions, step one is you're going to find your horizontal asymptotes. And you do that by looking at the degrees. So if your bigger degree is in denominator, like here, your highest degree is 1 right here, and that one's 2, so the higher, so that means your horizontal asymptotes will equal 0. If the bigger degree is in numerator, that means you have none. You just put none. We ain't done one like that. Same degree, you divide your leading coefficients, like I showed them a while ago. By right here, what's your highest degree? 1, 1. So your horizontal will be 4/3. Does that make sense? After that, you find your other points of discontinuity, and that deals with what makes the denominator equal to 0. So you have to factor it to see what you're working with. If you can cross it out, you remember that removable, that means there's a hole in the graph. If it's not, it's infinite, that means there's a vertical aspect. Step 3, you graph them. Step 4, you make a table. And the numbers you put in the table. The numbers that go in your table are you pick a value to the number to the left and right of each your vertical aspect, and you always choose 0. Okay.
All right. Do y'all agree with the numbers in that table right there? For 0, I got -0.6, -4 is 0.1, -2 is -0.6, 2 is -1.4. 4 is 1.2. If you're having trouble coming up with a table, please come to see me in 0 period tomorrow, okay? Yes.
So we're just going to round up to the nearest 10.
Yes, let's just do that, yes. Now, sometimes you might do 100, but that's your call, okay? As long as you know how to graph it.
Am I going to affect the whole lot?
Nope. All right, so let's graph this. Let's see, and we graph it to see if it crosses the what? Horizontal asymptote. Does it cross the horizontal asymptote? No. So we look at it. Now let's graph it. All right. So 0 is at -0.6. -4 is at 0.1. -2 is at -0.6. 2 is at -1.4. I'm gonna connect those. And 4 is at 1.2. And that would be my graph. I got time for one more. Because I won't see some of you tomorrow. And I didn't get as far as I wanted to, so we're going to do one more. Number 4. Horizontal asymptote. 1, because I got the same power, so 1 divided by 1 is 1. I need to factor this to see what's going on. Can I remove the x plus 4? Yes. So what would occur? So where's my hole going to occur at? X equals what? -4. Because if I set x plus 4 equal to 0, what's the one number in the universe I can't plug in that? -4. So because I can remove it, there's a hole at x equals -4. Can I remove the x minus 4 factor? So what's occurring? Where's my vertical asymptote occurring at? X equals 4. Do you see that?
I'm still trying to catch up on
Now, when I pick my values here, guys, what always goes into my x value? 0. Okay, and then I pick a point to the left and right of my what? Hole or vertical asymptote? So I pick 3 and 5. And I'm going to go and tell you the answers of this one. So 0 is -1/4, 3 is -4, and 5 is 6. Alright, so I'm going to graph my horizontal asymptote Now what we've done is the horizontal asymptote's been at 0. Well, now it's at y equals 1. Y equals 1. My vertical asymptote is here. I'm going to save time, tell you it does not cross the horizontal asymptote. Remember, I have a hole at x equals -4, 2, 3. So I need to come up here and put a hole to signify there's a hole in the graph. Just put a hole above or where on your line wherever you have it going near x equals -4, and that would be your graph. We're going to continue this tomorrow, but you have 5 problems on your try for homework. Juniors, it's imperative that you watch that video tomorrow because I'm going to go over homework and go over this some more, okay? Page 41, 42, numbers 19 through 23. We're going to review this again tomorrow. Have a good day.